I'm Dr. S. Jayapurni, Professor in EC Department at Sri Shanmuga College of Engineering and Technology. Today we are going to see about the objective of VLSI testing. So now we are going to see about the introduction of VLSI testing and its validation, the primary objectives of design verification, primary objectives of manufacturing testing, why objectives are crucial, and key fault models targeted by testing, a combined approach for success. So, introduction to VLSI testing and validation. VLSI, as the name refers to its very large scale integration, it is the process of creating integrated circuits with millions or billions of transistors on a single chip. The challenge involved here is it has increased its complexity to, and so there are so many errors and defects in it. So there are two various ways we can check the chip that is being manufactured, that is pre-silicon and post-silicon. A predictive analysis process to ensure the A pre-silicon, it is a predictive analysis process to ensure the synthesized design that will perform its intended function before fabrication. A post-silicon method is a manufacturing step to ensure the physical manufactured device so that it has no manufacturing defects. The goal is to finally to ensure high quality, reliable electronic devices. The primary objective of a design verification, it is first to obtain the correctness of design. Next, to verify the design whether it behaves exactly as mentioned by the system requirements. Third is to catch and to rectify functional bugs early in the design cycle when they are least expensive to fix. Compliance, it is to ensure the design whether it adheres to the industry standards and specifications. Evaluate the performance metrics such as latency, throughput, power consumption, and timing specifications. It utilizes simulation, formal verification, test benches, and assertion based verification. So, this is the verification phase and this is the validation phase. Here we have requirements gathering, system analysis is done, software design is being done, a module design is being done, and then a coding. In validation phase, we have unit testing, integration testing, system testing, and acceptance testing. These are the various testings that is being done at the validation phase. So all these verification and validation phase, they all are involved in order to make sure that the final chip that is produced after fabrication process is meeting the design requirements and that there are no faults like checkered faults, opens, shorts, like that. There are no faults present in the inside the chip. The primary objective of manufacturing testing, that is, identify the physical defects introduced during the manufacturing process, namely opens, shorts, stuck faults, to have a quality control, that is, screen out faulty chips before they reach the customer to achieve low defect levels. Example, for parts per million. Yield improvement, they provide the feedback to the fabrication process to improve manufacturing yield over time. Diagnosis, isolate faulty parts for failure analysis and repair. Methods, we use either automatic test pattern generation or design for testability techniques and automated test equipment, that is AT. Either of these things may be used to obtain the testing of the chip and to obtain the testing of the fabrication process so that the finally obtained the electronic devices free from any defects. The economic impact, why these objectives are very crucial means these electronic components designed are being used in healthcare, automotive industry, telecommunication industry, and consumer electronics. So the cost of the failure, that is the rule of 10 content, that is the cost to detect and fix a fault increases by a factor of 10 at each subsequent stage of production. So at the chip level, the cost involved is lowest. At the board level, it is moderate cost. And at the system level, it is high cost. If the same chip is being uh, done to various process, and if it is found any defect at the field, the cost involved is very high, and the reputation of the company also you might get damaged. So the testing aims to detect faults as early as possible in the design flow to reduce the overall cost. These are the key fault models targeted by testing. That is stuck fault, that is a single line is permanently stuck either at logic 0 or it is stuck at either logic 1. Bridging faults, and an unintended short circuit between two signals. Then the delay fault, that is a circuit transition is too slow to meet the required timing specifications. Or the transistor level faults, so that is the transistor is either stuck open or short, or often they are all detected by IDDQ test. So these are the various tests, and these are the things that are defects that are present in these chips, and they are targeted and they are found out by testing methods. So verification, these are the challenges, that is verification, testing, and the overall objective. It confirms that the design intent is met functionally, that is pre-silicon. It confirms that the physical implementation is free of manufacturing defects, that is the post-silicon, that is called as the validation. So the finally the overall objective is the integration of rigorous verification and comprehensive testing is essential for delivery high quality, reliable, and cost effective VLSI products to the market quickly and efficiently. Thank you.